Okay, this is question 27 now. It'll be fairly easy because this one doesn't really ask us to construct, I don't think. What is the maximum height the nail can obtain? So really you just have to understand your max height and you have to understand the question. So again, the problem is that some of this is in centimeters and some of this is in meters, so you have to convert it. Now wait, didn't we do 20? I think we did all this already. Yeah, we did all that stuff already. We want to do this stuff. There we go, page 1. Okay, simplify. There we go, let's start. Now notice that there's a division here. So the problem with this one is when you're dividing two fractions, you have to flip the second fraction and change to multiply. And we have to factor really before we do that to find restrictions. So down up top, we can see that there's a 6 in common and R2 in common. So we can factor out a 6R squared. And when we do that, the first one, we're left with R minus 1. Down below, we can see that there's an R cubed in common, and that's it. And when we do that, R cubed, do like this, R cubed, we're left with R plus 5. Let's factor this next one before we flip. Before you try to find the factors of the top one, notice that they always see if there's a number in common that you can factor out. There is 3. We're left with R squared minus 5R plus 4. This makes factoring this a lot easier because instead of looking for a number that multiplies out to 36 and adds up to minus 15, we're now looking for a number that multiplies out to 4 and adds up to 5, which is a lot easier to figure out. If it's 4 and minus 5, we're talking about the only one possible is 1 and 4. That adds up to 5. Because this is minus 5, they must both be, and because this is positive, they must both be negative. So we end up with this as a factor, minus 1 and minus 4. Down below, the same thing's true. I can factor out the 2, and it's going to make my factoring a lot easier when I'm trying to find this, R squared plus R minus 20. Now I can see that I have to find a number that multiplies out to minus 20 and adds up to positive 1. When something adds up to positive 1, the factors must be very close to each other. The only factors that could add of 20 that can add up to positive 1 are 4 and 5. And one of them must be negative because the 20 is negative. And since the 1 is positive, it must be, the smaller one must be negative. Minus 4 plus 5 is indeed plus 1. So right away, my factors are minus 4 and plus 5. Two, R minus 4, R plus 5. Before you cancel anything, we must find restrictions, and don't cancel yet. You shouldn't cancel yet because it's a division, and I'll explain why yet in a second. Down below, the two possible things, R can't be 4. You simply make this equal to 0 and solve for R. Add 4 to both sides. R can't be 4. Same thing for this. R can't be minus 5. It's any bracket cannot form 0 because you'd have a 0 as a denominator. So R plus 5 equals 0. Subtract 5 from both sides. R cannot be minus 5. Over here is minus 5 as well. But here it's just 0. Whenever you have an R all alone that's multiplying something, R cubed here, if R was 0, this would make a 0. Would make the whole bottom 0. So here's our restrictions so far. Don't stop. Don't cancel yet. R can't be 4, minus 5, or 0. Now, before you cancel, because this is a division, when you divide two fractions, you change this to a multiplication. I'm going to just use a dot. And you flip this fraction, you take the reciprocal. So this is going to go up top. Like that. Now we have to look for restrictions again. R can't be 1, R can't be 4. R can't be 4 is already there. So all we add is can't be 4, 0, or 1. And you would put that in order. -5, 0, 1, or 4. That's what R can't be. And then you put your restrictions aside, and then you work on cancellation. There we go. Now I can see there's an R4 up here and an R-4 down here. As they're all multiplying, you can cancel across as well. See, there's an R-1 here, an R-1 here, an R+5 here, and an R+5 here. I can see that the 2 times 6 is 12, and the 3 times R3 is just 3. So you're going to be left with 12R squared over 3R cubed. Now there's even more cancellation, and this is why we find the restrictions first, because all those restrictions are gone now. 3 can go into 12 4 times, so 3 goes into 3 once, and 3 goes into 12 4 times. Now the normal thing is, for the same base, here R is the same base, is you take the exponent and you subtract them. It would be 2 minus 3, which would make the R up here, R to the -1. But the simpler thing to do is when this, and R to the -1 simply means the R goes down below and is a power of 1. So we'd end up with 4 over R. But the simpler thing to do is to say, this exponent is bigger than this, therefore this goes into this twice, and I'm left with an R down here. 4 over R. To visually understand this, remember that 4R squared is simply 4 times R times R. And R cubed is simply R times R times R. And it's clear that these two R's cancel with these two, any two R's down below. And I'm left with 4 over R. That is the final simplified version. 4 over R is the final answer. But all those restrictions apply. You cannot forget your restrictions. Good. If you were to graph this out, this is if you were to put this into Desmos, this is the only hole you would see, or the only asymptote you would see. The rest of these would create holes because they got canceled out. So you'd see something that looks like this. And then at -5, you'd see a hole. At 0, you'd see a hole. At 1, you'd see a hole. And at 4, you'd see a hole. And when there's a number up top and letters are down here, y is equal to 0 is the horizontal asymptote. It might cross that as well because of this 0 over here. But they don't want you to get into that depth. Next one. To find the domain of the next function, we have to understand what's canceled, and we have to understand a little bit about reciprocals. So this is clearly a reciprocal because there's top and bottom. And since they ask for the domain, clearly they don't want you to understand ranges, which is fine because ranges for these things are quite complicated. But to find out the domain, you have to understand that for a reciprocal, the domain is always XER except at the asymptotes. And asymptotes are created at the bottom. Now, when things cancel, they don't create an asymptote, they create a hole. However, that hole also counts as a restriction in the domain. So for instance, you'll often see XER, but X can't be 3 and -2 or something like that. And that'll be where the asymptote is. It'll be at 3 and -2, let's say. And that means the factors down below would have been X minus 3 and X plus 2. But we'll see that in this specific example. So it means we have to factor, and we should factor top and bottom. So up top, we're looking for a number that multiplies out to minus 24 and adds up to minus 5. That's how we factor. We look at A times C, and we're looking what adds up to B. Well, A is 1, so really we're just looking at C, and what adds up to B, which is minus 5. So that means the factors are going to be 5 apart, whatever this is, and there aren't many factors that are 5 apart, and 24 and 1 we know is too far apart, and we know 8 and 3 is too close. So even if we go 6 and 4, that doesn't work. And then we discover, 12 and, no, not 12 and 2, 8, let's see, 8 and 3. Sorry, that is 5 apart. We can also see this is negative and this is negative, so that means one of these is going to be negative. And since this is a negative number, the biggest number is going to be negative. So it's going to be minus 8 plus 3, which means the factors up top are x minus 8, make it a little bit bigger, and x plus 3. Still going to make it bigger. And that will not dictate, you might say, well, why are you doing that if the denominator dictates a whole, the asymptotes? You're right. Technically, I wouldn't need to do this, but I should, if I was going to continue on in functions, I should learn what creates a whole and what creates an asymptote. So for this one, we're looking for a number that multiplies out to minus 30. That adds up to minus 7. Almost right away, I can see that 30 and 1 doesn't work, but 3 and 10 works perfectly. So this is a negative number, and this is a negative number, so one of these is going to be negative. This is the negative number down here, so the bigger number is going to be negative. It's going to be positive 3 and negative 20, which means the factors down below are x minus 10 and x plus 3. Now, what asymptote it creates is when either one of these becomes 0. Either one of these becomes 0. And if you were to ask restrictions and try to remember that your teacher is indeed asks questions that are not on the review, your restrictions are set like this. You make your x minus 10 at the bottom equal 0. You solve for x, so x can't be 10 because it would create a 0 in the denominator. And then you do it with the other one, and if you do it with the other one, you can see that x can't be minus 3. So that means x can't be minus 3 or 10. And that is what the domain will be. You'd say XER, except x cannot equal minus 3 or 10. Like that. You put a little stroke through this. Now, I also want to say, you can see right away, now that you've got the restrictions, and it's important because that created our domain, but you can see right away there's some cancellations. Cancellations show that there's a hole in there, not a asymptote. Since this one didn't cancel, if I were to be asked to graph it, I would put down my Cartesian graph, and where x is 10, remember it's the opposite of that, over here there's going to be a asymptote. Then over here at minus 3, so my graph's going to look like something like this. And over here at minus 3, there's going to be a hole. This is easily proven by putting the original graph into Desmos, or the original equation into Desmos. And you will see, when you go over to minus 3x, you will see a hole. When you go over here, you'll discover the graph never hits 10. However, our holes or asymptotes still restrict our domain. So this is still the domain, whether it cancels out into a hole or not. Okay, let's move on. Okay. Which of these represents factoring this by grouping? Okay, so graph number 9. Okay. So grouping is this. So you take your thing, and they told us we're going to do grouping, and the whole goal is one bracket on the left should match the bracket on the right. Okay. So we've got g cubed plus 5g squared plus 2g plus 10. The only way to factor it is to factor these two separately, and then factor these two separately. let's look at what this has in common. Well, there's a g squared here and a g cubed, so the maximum I can take out is g squared. There's no number here, and that's a 5, so the only thing I can take out from the left is maximum g squared. When I divide both those things by g squared, and for this you need to practice, I get g cubed divided by g squared leaves g, and 5g squared divided by g squared leaves 5. And on the right, there's no g in the second term. There's the number 2 and the number 10. They both have 2 in common. So I can factor 2 out. If I take 2g and divide it by 2, I'm left with g. If I take plus 10 divided by 2, I'm left with 5. Notice my second bracket matches my first bracket, which probably means I've factored correctly. So my two factors is I take that bracket, and then I take what's left. G squared plus 2 is what's left. And those are my two factors, so I just have to see what this matches. Notice that this one can be excluded right away, and so can this one, because these factors never end up being added. They end up being multiplied. As a matter of fact, if you were to multiply these out, you should end up with what you started with. There's never a plus between the factors. So right away, you could have ruled out those. This is very unlikely here, so almost right away you could have gone with this. Now, let's see what's going on here. Why isn't this right? So it should be g squared plus 5 and g squared plus 2. So it's not that one. And, oh, they didn't group it. They didn't regroup it, so they left it in this stage. So yes, there is a positive between it at this stage. Really, it should be rewritten like that. But I think she's being kind and not making students learn how to take this bracket here, put it there, and take what's ever remaining and put it there. So she's left it in this stage, which would have a plus between them. So that means A is our answer. Let's see, that's almost impossible, and that's almost, well, that's sort of possible, but unlikely. So it's that one. Okay. So which pair is equivalent? Sorry about that break. I meant to pause the recording. Which pair is equivalent is the next one. And here we go. The only way to do this is to expand them out. Now, there is a little trick. You can expand just the numbers out and see if they match. So for instance, it would be 7 times 12 plus 7 times plus 12, which is 84. And then plus 3 times minus 23, which is, this first one was plus 84. Bad 84. And this next one is minus 69. So 84 minus 70 would be 14. So minus 69 would be 15. So that means the numbers should match. I should have a 15 on my bottom one too. 6 times 11 is 66. 10 times minus 9 is minus 90. Clearly, 60 minus 90 is minus 30. They would not match. So that's the quick way. Otherwise, what you're going to spend time doing is you're going to expand this, and this, and then this, and this, and add them up. Personally, I think the number method is better. Your teacher probably wants to see you do it the long way. But let's see if we can spot the right one with the number method. Down here, there is no number. No number at all, and we can just add them. 14x squared plus 8x squared is 22x squared, plus 5x plus 19x is plus 24x. 22x squared, check. But that's not plus 24, that's plus 23. That was pretty tricky, pretty close. This one is also already pre-expanded. Note that this minus has to be distributed through both these terms. So this minus will make this minus 2x squared, and it'll make this plus x, 8x minus. It's like having a minus 1 multiplying anything. I can do 14x squared minus 2x squared is 12x squared, check. Minus 5x minus 8x is minus 13x. Note that if you did not correctly apply that minus and you added the 8x to your minus 15x, it would give you plus 3x. That's some trickery on your teacher's part by making the mistake match, but it does not. It's actually minus 5x minus 8x, it's minus 13x. Finally, it pretty much means this one must be it, but let's make sure. We're going to do our number trick. 3 times minus 11 is minus 33. And then minus 79. So we can just say, what's 30 minus 70? It's minus 100. What's 3 minus 9? It's minus 12. So we're talking minus 112. 6 times minus 10 is minus 60. Note that the number over here is first, so we have to minus 4 times minus 13. So this was minus 60. Minus 4 minus 13 is minus 52. Minus 60 minus 52 are minus 112. Boom, the numbers match. You then have to go back and make sure the squares match. 45x squared plus 19x squared is 54. Hang on, 45x squared plus 19x squared is 64x squared. 36x squared minus, so that makes plus 28. So 36 plus 28 also makes 64x squared. So the squares match as well. So really this number trick helps. Notice we had to go through all 4 to get to the right one. This number trick helps to speed it up. Okay, moving on. Yeah, so just practice the expansion. I'm not going to expand it. You can also use that rectangle method for this. Because 7 and 3 can go, 7 can go along the side, and that can go along the top, and you can expand it. But it's pretty easy to expand these things. And, you know, if you want, I don't know if you need one example. I'll do the first one as an example. No reason for me to do all of them. Or I'll do the last one as an example to prove that that's the one. 3 times 15 is 45, and then there's the x squared. Then 3 times 11 is minus 33. Then they don't even have anything, so it's just plus x squared minus 79. When I add up the like terms, it's 45x squared plus 19x squared, which is 64x squared. You have to add up your like terms. And then minus 33 minus 79 is the same as minus 30 minus 70 minus 3 minus 9. This is clearly minus 100. This is clearly minus 12. And this is clearly minus 112. So that's what this expands out to, the first one. The second one, 6 times 6x squared is 36x squared. 6 times minus 10 is minus 60. Minus 4 times 13 is minus 40, minus 52. And then minus 4 times minus 7x squared is plus 28x squared. Put your like terms together. 36x squared plus 28x squared. That's the same if I'm going to borrow 2. I'm going to borrow 2 from the 36 and make it 34 and give it to this 28. It's clear that 34 plus 30 is 64x squared. And then it's minus 60 minus 52 is the same as minus 60 minus 40 minus 12. Clearly, minus 112. So they match. This first one expands to that. The second one expands to the same thing. So the answer is D. Okay, continuing on, this one's pretty straightforward. Which one of these functions fits this definition? They're showing you a translation. It's a very easy question. We're going to analyze each of them. Clearly, this is a quadratic. And guess what? Oh, sorry, not a quadratic. A radical. And guess what? You can see the vertex right in there because the x values all shift to the left by 9 and the y values are all shifting up by 1. So the normal vertex of a radical is at 0, 0. So if we shift left by 9, it's over here, minus 9. And if we shift up by 12, it's up here, minus 9, comma 12. The next thing you have to do, well, you don't have to do it for this question. I'm just clearing up what this one is. You can see that it has a stretch by a factor of 7. So it's going to be very thin going whichever way it's going. And then it also has a compression by a factor of a fifth. So it's going to be even thinner, very stretchy. But this minus here is a reflection in the x-axis. So instead of going up, it's going down. That said, that doesn't matter. What they're asking is which one of these things matches this. We have let's start at the end. A horizontal translation 9 units to the right. No, x does the opposite. It's tricky. It's the opposite. It's 9 units to the left. A reflection in the y-axis. No, when the negative is at the y value, that's called a reflection in the x-axis because all the y values go from this to the opposite side. Horizontal stretch by a factor of 5. No, when it's in front of x, it's the opposite of what you would think again. And so that would be a compression by a factor of 1 over 5. And then finally, a vertical translation 12 units up. Yes, that's what's going on there. And if, remember that Desmos is your friend, it's very good to throw in the Desmos. And then you get this. It doesn't really matter if I get the numbers quite right. Minus 7 square root x minus or plus 9. And oh yeah, there was a 5 in there. And then plus 12 up. So you can see, oh, it's actually stretched. Yeah, stretched vertically. I stretched it horizontally. It's going to be stretched because it's compressing x and stretching y. It's going to be horribly stringy straight down, not straight to the right. In any case, it does indeed start at minus 9, comma 12. The domain is xer. Oh, sorry, xer. X is bigger than minus 9. And the range is yer. Range is y is smaller or equal to 12. X is bigger or equal to minus 9. Y is smaller or equal to minus 12. And that's because of the reflection in the x-axis. Next. So this one is also relatively easy. They're saying we have a graph and we're just going to call it f of x. This is when essentially what they're saying is the graph doesn't matter when they say y is equal to f of x. We've got a graph, that's what they're saying. They want to say what happens when we change that graph. In other words, when we take f of x and we add this to it. So the big thing is to figure out what that is. Be aware that y transformations will be outside of the bracket when expressed like this. So this is not a y transformation. And there are no y transformations, which means the y value of 6 will not change. However, this 4 in front of the x is the only thing that's going on. Keep in mind your teacher might add extra because that's in her nature. And you'd have to apply all of it. But that 4 in front of it means we have a horizontal compression by a factor of 1 over 4. It means we multiply all our x values by 1 over 4, or if you want, divide them all by 4. 2 divided by 4 becomes 1/2. So the point we're talking about is a half. 6 stays the same because there's no y transformations. In decimals, it's 0.5 comma 6. Doesn't matter what the graph is. That's what happens to that point that they've given us on the graph, and it's been transformed. Next, number 4. So to do inverses is very tricky. She's given you a very easy one in a line, but just remember, she might not give you a line. She might give you a quadratic. Quadratics have to be put in the vertex format if you're going to inverse them. She's given you this one because it's very hard to teach inverse, and she skipped inverse in the class. But here's what you do. You replace f of x with y, first of all, and you should also keep your line in the order of a proper line, which is mx plus b. So usually the x, no matter what, it always goes highest degree x, or a highest exponent x, next exponent x, and next exponent x, all the way down to the number. Now notice it also hasn't got that -5 correctly done, but we'll just leave it as is. The inverse, the first step is you're going to switch your x and your y values. And the next thing you have to do is you have to get y all alone. Now, whenever there's a missing value in here, that is when you use reverse BEDMAS. Not when you have all the values, when you're trying to get y all alone. So reverse BEDMAS would be, since BEDMAS is this, then reverse is this, which means we look for subtraction and addition first that's outside of brackets, and sure enough, there's an 8. So we have to do that first. We add 8 to both sides. And we get this. X plus 8 is equal minus 5y. Since there's nothing left in terms of addition and subtraction, we can get rid of everything about addition and subtraction. Sam Dem. So we've gotten rid of the first two, addition and subtraction. We have to ask if there's any multiplication or division. There is indeed a multiplication. It's being multiplied. There's no division, so I'm going to get rid of it. So we have to divide both sides. So we got always put anything that's being added when you're dividing something, divide both sides by -5. Now, there's two ways you could do that. You can divide both sides by -5, and you're going to get this over here. And now you're going to get y all alone, and that's a legitimate answer. This is indeed the inverse of that line. But it's not correctly stated in the y is equal to mx format that I stressed in the beginning, is it? So let's bring that back. So instead of dividing by -5 on each side, what we're going to do is a little thing called multiply by the inverse. What's the inverse of -5? It's -1/5. -1/5 on both sides. So on the left side, again, we have to add a bracket. And we're going to multiply it by -1/5. Over here, when you multiply a number by its inverse, it disappears. Essentially, the negative becomes positive and the 5s cancel out. So you're left with y, but you're still technically not in the MXB format on the left, and your teacher might not care. She might have accepted divided by -5. No problem. Just keep in mind the minus has to go up because we don't keep the minuses in the denominator. So you just slide it up in front of that bracket. However, in this method, we have to distribute -1/5 over times x and -1/5 times 8. So x just becomes -1/5x, like that. And what happens when you multiply -1/5 times 8? Well, 8 is just over 1, and multiplying fractions is easy. You just multiply the top, and you multiply the bottom. So we're left with this, and you should keep your x in a bracket, -8/5. And this is indeed, so it's y is equal to. This is indeed the correct expression of the line because that tells us the slope, -1/5. So it's going down very slow. It's going down 1. It's going down 1/5. That's what rise over run is. The negative tells me it's going down. And it starts at the y value of 0, -8/5, which is the same as, if you put that in decimals, it's 2.6, I believe. I think 5 with 3. I think it's 2.6, so -2.6. So it's going to go through the point 0, minus down here. So I drew my line on the wrong side of the x-axis. It's actually down here at -2.6, and it goes down 1/5, down 1/5, down 1/5, and you just connect. It's a line. The other one, starts way down here at -8, and it's also going to be a negative value. It's -5, so it's actually going to go down much sharper, like that. You might, and they will cross somewhere on this side. You might see that. How's that a reflection in the y is equal to x line? Well, if you did this, you'll see that it's perfectly balanced on either side. And that's again where our friend Desmos is very handy. You can skip this part if you want. So we had -5 and then x, and then it was plus, what was it, +8? Or -8. There we go. -8. Oh, did that become a plus on the right side and I changed it to a minus? Oh no, it got multiplied by -1/5. Okay, so that's that line. And of course, the inverse can be expressed, as I said, if your teacher might accept, as x plus 8, just divided by -5. But keep in mind that minus should go up here. So she might accept that. But the same thing can be written as I did, which is -1/5. X -8/5. And there you might say, okay, well, I still don't see it. So you've got to draw y is equal to x line to see it. And that means these things will mirror, they'll meet at the y is equal to x line, but they'll mirror everything on the side. You can prove it by finding a point, -1.6, 0, and finding the flip of that point, 0, -1.6, on the green line, which is there. And that happens to be the y-intercept, by the way, -8/5. Any spot I find on this line, for instance, up here at -3, 7, I will find a 7 -3 over here. And that's how you know you did the inverse correctly, because every point on one line should be able to flip on the other line. And if you look carefully at that purple line, if I find a point here and I go through the purple, it's on the opposite side of the purple like a mirror. So if I find this point here, -2, 2, I go straight through the mirror and I find it at 2, -2. It's like the purple line is a mirror. I can find the exact points on the other side of the mirror. This one's extremely tricky and kind of mean. Okay, well, we're almost wrapped up. What is the domain and range of this function? It's a square root function. I don't think I did this, but in any case, yeah, I didn't. So it's number 3. And the first thing you should note that when it's not expressed the way you're used to, you're not going to get a good idea of where the transformations are occurring. So as you might remember, we always put our x's first. So we would put an x plus 3 instead of the way it's written. Then we would note that, hey, Peter always told me you don't want your x to start with a negative. So we should factor out that -1 from both terms, which makes it, when I divide both terms by -1, I get that. Now, both of those things are inside the square root function. So we should understand the square root function. We should also note that because it's inside the square root function, these are only x transformations. There's no y transformations. Normally, the square root function starts at the point 0, 0, and goes up like this. Now, this -3 actually shifts all my x values to the right by 3. But before that happens, I have to look at what this is. Now, in this case, when it's 1, it doesn't matter if I inverse it, because 1/1 is the same. So it doesn't matter if I divide by -1 or multiply by -1. But we'll take it as it should be. I would take all my x values and divide by -1, and then add 3. So if I take 0 and divide by -1, it's still 0. And then when I add 3, it's going to move to the right by 3. But the problem is, this -1 is a reflection in the y-axis. So while it starts at -3, normally going this way, this is the y-axis. So it's a reflection in the y-axis sends it the other way. You can easily discover that if you take 2 points. So another common point on this curve is the point 1, 1, and then 4, 2. Those are 2 other points. And if I apply these transformations, which are just to the x value, so if I take -1 and I divide by -1, I get -1. Then when I add 3, I get +2. Let's see if that works. So I get -1, and then when I add 3, I get +2. But plus 2 is to the left of plus 3. So it's plus 3, comma 0. And the y value stays the same. So it becomes 2, comma 1. And then if I look at the 4 value and I divide it by minus 1, I get minus 4. And then when I add 3, I get minus 1. So that means the next value is at minus 1, comma, and the y value doesn't change. 2. It's clear if x is 3 here, and x is 2 here, and x is minus 1 here, that my graph is going this way. Which makes my domain x smaller or equal to 3, because 3 is on the point. And it makes my range unchanged because there were no y transformations, and the normal range of a y root function is y is bigger and equal to 0, and that did not change. So that means the domain is now x is smaller and equal to 3, which is the new y value, x value of the vertex, and you couldn't see it from the original. And x goes, and it, because of the reflection, it goes that way. So x is smaller or equal to 3, y is bigger or equal to 0. So in a script that you can read, it becomes x is small, xer slash x is smaller or equal to 3, yer, y is bigger or equal to 0. Now we're going to go down to the last two, which are pretty simple. Dwayne walks 8.41 kilometers, and then he ran at a speed. So this is really mean, one, because I doubt many students understand how to convert speed to distance. But we know that at the very least, the total distance that Dwayne walks is expressed like this. Total distance Dwayne walks is his walking distance plus his running distance. And because I want us to do a function that shows the distance he walked and ran, which is total distance. So they want it in distance. Well, his walking distance is given. But his running distance is not. His speed is. Speed is where this is mean. If you think of kilometers per hour in your car, which is the speed it goes, kilometers is a distance and hours is a time, which means speed is equal to distance divided by time. Well, they want us to express it in terms of distance. We only have been given the speed. We have not been given the time, so we'll just represent it as t. We want an expression of distance run based on the speed. And I don't have it all alone. I'm being divided by time, so I have to multiply by time on both sides. I'll put this in brackets. It disappears. So that means distance run is equal to his speed times his time. And they've given us his speed. And his time is like that. Just t. We don't know it. So I can replace distance run with this. Now, if you think of in terms of x and y, it's really this, isn't it? It's really y is equal to 8.41 plus 11.2x. We rearrange that. It's very clear what kind of graph this is. The line, but we put it in functions. Distance based on time is equal to 11.2 times the time plus 8.41, which is considered the constant. We can see it times 0. When time is 0, distance is 8.41, which makes sense because he walked 8.41. So this would be a formula. It's clearly a line formula where the y-intercept is 0, 8.41. The slope is 11.2, which is his speed. Slope of a distance over time graph is always going to be a speed because it's rise, which is distance, divided by run, which is time, which gives you speed. And there you go. That is an expression of his distance based on his speed and the distance he walked. Very annoying question because you have to understand what speed is. Which relation is a function? I'm going to tell you right away that anything with x squared and y squared in it is not a function because it's going to form a circle or a hyperbole, neither of which will pass the vertical line test. You'd be tempted to say, okay, well, that's a circle, so that's not going to work. And that's a circle. And the easiest way to say right away is, well, that's a parabola. And I know a parabola is a function, so right away I know that's a function. But you might be tempted to say that this is. But we don't have y all alone here. We have y squared. And you might say, hey, that's still a quadratic because I can square root the right side and the left side and come up with this, minus x. plus 3y. But you'll notice right away we got a problem. There's a y over here, so that's impossible to do. We'd have to bring y over and try to get y all alone and all sorts of things. But even so, when I take the square root of x of y squared, I'm supposed to add a plus and a minus, which means I'm going to create a sideways parabola that will not pass a line test. So right away you can just say, well, that's a parabola. That's definitely a function, and that's what you should do. And that's it. Good luck.